another supply chain attack, a major one has happened, and I'm going to not talk about it. So let me share my research with you. Great. So this is one of the larger breaches which has happened. So what got breached? The package is called TanStack, which is an open source application for the web, and pretty popular. As you can see, that it is trusted in production by some of the top companies out there. Now, what is impacted? Mistral AI's code is out for sale at 25K USD. OpenAI also admitted, as in their blog, that it has impacted two of the employees. Now, who is behind it? It's the same team PCP. If you remember, a month back, we have covered on the light LLM, and during that point of time, it was again team PCP. So this campaign which they are running is called Mini Shai Hulud, and this is an Arabic term which means thing in eternity. They are doing something big, and this is not just one sort of cyber attack. Sorry, one sort of supply chain attack, but it's going to be something massive which is getting brewed. I'm going to cover that probably later. We are still doing research on that. Now, going more into details, right? If you see what is the modus operandi, the attackers exploited a specific sequence of vulnerabilities in the automated systems GitHub uses for test, basically test and publish. So first thing is that the attackers faked the contribution. So from a separate account. So they used a specific setting called pull request target, which is meant to automate tests, but can be dangerous if not handled strictly because it gives outsiders more permissions than usual. Cache poisoning, they infected the temporary storage that GitHub uses to speed up tasks. By doing this, they ensured that when the official TanStack system ran its next job, it would incidentally load the attacker's malicious files. The memory heist, which is essentially the third step, once their code was running inside GitHub's brain, the runner process, they reached into the computer's active memory and snatched the OIDC token. Now, why this OIDC secret is important? So this is most important part. In the past, developers had to save permanent password on GitHub to publish the updates. Now, if that was stolen, the hacker could use it forever. So TanStack started using this newer, safer method called OIDC, which is nothing but OpenID Connect. Now, instead of permanent password, the system generates a temporary hall pass that only works for one specific job. The good news is that because it is temporary, the hackers did not own the account. No permanent passwords were stolen. The bad news, however, is that the hackers caught the hall pass while it was still valid and used it to upload a file, the malicious version of the software, to the NPM registry. So the key takeaway here is that no keys were lost. The workflow was okay, but the impact was that even though it was a sophisticated change attack, it was limited to the specific moment the attackers were active. So we have written like the thieves did not break the lock. They snuck into the building while the door was already held open for a legitimate delivery. Now, well, we understood the technicalities of it, but what is essentially our remedy? So remedy is a 7-step immediate steps and then a little bit of advisory at the end. So first step, immediately run this command on all your router init.js and match it against this hash, which we have mentioned over here. Rotate all the secrets immediately on any system that installed this affected TanStack. Version revoke GitHub action OIDC federated grants for any NPM package published from affected repos. Reestablish only after confirming the publishing workflow has not been tampered with. You can audit the Claude, VS Code, or whatever you're using in all the developers' home directories and project roots. Remove router underscore runtime.js, setup.mjs, and any unfamiliar entries in settings.json or task.json. So review your recent commits to your GitHub repositories. You should not become the next TanStack. So scan NPM publishing logs for any unexpected publishes from your organization, particularly versions published from GitHub Actions runners that were not initiated by a team member. Finally, block file v2.get session and related session infrastructure at the perimeter if not in active use. The IP range for session service node network is distributed, so DNS level blocking is more effective than IP rules. So three advisories: implement sub-resource integrity or package log verification with a pin integrity field. Restrict OIDC token scopes in GitHub action workflows. Do not merely trust the six-store provenance badges, because this attack showed us that this can be compromised. Further, if you need any help, do reach out to us at zapshield@responsiblei.com. We are very happy to help, like how we are happily helping our customers today. Thank you so much.